For me, it is a new tool in the toolbox. I have access to AI agents and AI tools, but you need to be able to leverage it effectively, understand the pitfalls.
You need to know how to drive it and need to understand how do you interpret the results. The big hallucinations that you got for the early LLM models, and there's no way we can deal with that in engineering.
The future AI agent is going to be equivalent to a human. Exactly like an interview process. Is this the right candidate for this right job? Is this the right agent for the right job?
Really see it as people say, oh, people might lose, jobs or whatever. The result is that we just do more.
Ladies and gentlemen, welcome to a new podcast episode here in Amsterdam at Realize Live 2025. Today with me, John and Yeshwant. Welcome to the show.
Thank you.
Today we'll talk about the topic of generative AI, how AI is impacting the engineering topic and job role in the future, but also how AI can be used for post, pre, and processing when it comes to simulation systems and development. Maybe John, let's start with you. Give us a quick introduction to yourself. Who are you in the first place and what do you do at Altair?
My name is John Skarakis. I'm one of the chief engineers and I'm responsible for modeling and visualization, mainly for all our simulation solvers and tools.
Great. Yeshwant?
I'm also one of the chief engineers responsible for HPC, analytics, Altair One, and cloud portfolio of products based in Troy, Michigan, USA.
Excellent. We'll start with a very general question and broad question to kick off the conversation. What does AI in engineering mean to you, John? And then we'll follow up with Yeshwant.
AI engineering, just to put it in general terms, to me means how we can take advantage of all the developments in machine learning and training, AI agents in specific in the simulation or engineering in general. So let's say a more focused subset.
Mm-hmm. Interesting. Yeshwant?
For me, it is a new tool in the toolbox. Okay, so I view it as, just to give you a context, my dad was a mechanical engineer. When he went to college in 50s, he used slide rules and, manual drafting. And when I went to engineering, I had calculators, and nowadays people use computers. And the next generation is engineers are going to use AI to make their life, easier, more productive, and to bring innovative product to market in a much faster fashion.
Absolutely. I'm going to ask a bold question. So everybody talks about large language models now. So if you look at the development of software, we have software 1.0, where people write code to actually tell the computer what to do. Then we have software 2.0, which was deep learning systems, but the hype started with AlexNet, right? And then we have software 3.0, where people actually give a prompt to a system, which then does something. You talked about the development, Yeshwant. I want to know from you guys, is it more like a positive trend, or do we have to be careful? Because if engineers of the future prompt a system, but they don't understand the underlying physics anymore that deeply, is that a good or a bad thing? And what can we do to prevent this problem?
I feel that it's truly a tool. And in order to use a tool, you need to have a good understanding of the domain. Just because, I have woodworking tools, it's not that I'm going to become an expert carpenter. So similarly, I have access to AI agents and AI tools, but you need to be able to leverage it effectively so that you understand the pitfalls and not make crazy mistakes. So I feel that you need to have a general understanding of the domain, and this whole notion of formal education is going to blur maybe in future. But the whole idea is that you need to have some sort of understanding of the domain that you are trying to leverage a specific AI tool to be more productive and to be more knowledgeable.
Mm-hmm.
Yeah, I can continue with that. We have a saying in engineering, junk in, junk out, right? And AI is definitely, another tool. And you need to know how to drive it and need to, understand how do you interpret, the results, that you get and use your engineering, knowledge and judgment as you do with any other, tool. Also, I think for me, very key is engineers are trained, out of school, how to use tools and do things in a certain way. It's important for them to be able to efficiently utilize, the AI tools, that those don't feel like something different, but they blend it seamlessly into what they do. It just makes what they do easier and more efficient. This way, it's not a relearning process. I can give you an example, like our physics AI tool we treat as another solver. So even if you use like, Nastran or, OptiStract or Dyna or Radius, physics AI is just another solver. You get results, out of it. It's just that you get it very fast.
That makes sense. I'm wondering, Yeshwant mentioned something very interesting. Do you feel like a lot of engineers nowadays see AI as an opportunity, but also every problem to a lot of engineers looks like a nail? So they just want to throw AI at it. How do you see that?
To me, it's again going back to what John is saying. For general applications, hey, book me a flight ticket. How do I go from point A to point B? These are basically general life understanding. But even at that level, if my son uses it, who has never traveled internationally, and he misses the nuances of international flight travel, and he gets a schedule from AI, and overlooks the time zones, overlooks the layover period, and he may get into trouble with that schedule, right? So even as banal as a flight scheduling agent, you need to have some understanding of experience of travel to be able to effectively leverage the tool and understand what it's giving, so that you can make the appropriate decision, right? So, and that burden is even more when you write software, when you design something, maybe that is more mission critical. I truly believe that the operator should be skilled and should be familiar with the area that he's trying to exercise that specific AI agent.
Mm-hmm.
Yeah, and I think this goes back to the point that I was making also before. How do we blend, this, together? Because in order to get good results, you need to train a model. If that is becoming a very complicated, process, we have to train, our engineers to become, data analysts to do that. That's where I think problems will start, happening. But if you have the right, tools that, somebody, reads a model and you have an, or AI sorting it out, for them, and does all the bookkeeping and the logistics, for them, then it's something that, engineers will use it. Then they will use it a lot because they get rid of all the boring, let's say, part, of the job, and, all the effort on keeping things meticulously, because that's how you need to, to proceed in order to analyze, data. And not everybody is as diligent as, so you need to put that burden onto the tool, not to the user. Then I think it's successful.
And more importantly, in the future, AI agent is going to be equivalent to a human, right? So all the checks and balances that you have around humans to operate, you need to have similar checks and balance against AI agents, right? Exactly like an interview process. Is this the right candidate for this right job? Is this the right agent for the right job? What are the checks and balances that I need to put if you're going to roll this thing out in an autonomous fashion with no human in the loop? But obviously, I think it's going to be every adoption is going to have its own journey with human in the loop, with appropriate checks and balances. So if you think about it as a buddy, whether it's a coding buddy, my brainstorming buddy, or my travel agent buddy, then you need to go through the same checks and balances as you would have it in real life, as if you're interacting with a person.
Mm-hmm. I'm wondering from the application point of view, you mentioned physics AI earlier, John. Where are engineers actually today using AI effectively already?
I will say for us, physics AI is a very good example because we can save many hours of actually solving time. And this enables us to run through optimization loops or generative design loops and pick what is the optimized solution for a particular, let's say, case. And then we only need to do a verification check to one or two cases that we come up on the top. So in essence, we can save thousands of solver runs, which each one could be hours, and now they could be down to seconds, and only do a few runs, at the end. Another example is our, Shape AI, where we, instead of manually sorting out a model and identifying what part is what, we train a model, to do that, and the model, the minute we read it, a model is already divided the way we want it. the tool already understands that this is not just the part, but this perhaps is a front right suspension. That is a very important knowledge, for downstream, that before we had to, let's say, manually, create it, where now it can be, generated based on, shape AI, models. Also, this clustering not only helps us set up a model, but also set us sort through results. We did, let's say, many runs because we're doing an optimization, and we get certain behaviors, collapse one way, another, and those could be, clustered for us. So we can only have to look at a mode that is interesting to us, because this is, we know, absorbs, more energy. So we're only gonna look out of a generative, let's say, design that could be thousands of runs, only 50 of them, because those are meeting the criteria. And now combining all that we don't have to do full runs on this. On top of that, now it can helps us focus on what's good, and this is where the potential savings are in time. And at the end of the day, I don't really see it as a saving, or people say, oh, people might lose jobs or whatever. The result is that we just do more.
So basically, you're saying it's more like an upward spiral than a downward spiral.
Exactly.
Okay, interesting. We'll talk about AI agents, Yeshwant. I'm personally super excited about AI agents. Tomorrow I'll give a talk on AI agents in engineering, and Google even said 2025 is going to be the year of the agents. How do engineers use agents today? And my personal concern is, how do we deal with RAG systems? How do we train or build RAG systems in engineering? And also, what are some of the security concerns that we have? Maybe these systems deal with amnesia to some extent. They forget a lot of things, and hallucination that we also have to talk about. So how do we tackle these challenges as well?
Briefly mentioned about having the proper checks and balances, right? So the RAG is one approach to implement that. So now we have graph RAG, which is which has not only the factual information, but it has the semantic understanding, the ontologies, the taxonomy. So it kind of understands whether you're talking about Apple, the fruit, or Apple, the computer, right? So that kind of semantic understanding is absolutely important for AI agents to, when agents are involved, and especially in a multi-agent environment in future, where humans are not in the loop to disambiguate information. Hey, I'm not talking about the computer, I'm talking about the Apple. Agents have to figure this thing out, right? Mm-hmm. So a graph-based, RAG kind of makes perfect sense for me, and that's what we have been investing in, and internally for our customers to develop their enterprise knowledge graphs. So when they develop AI agents, their agents are grounded in reality, and they have a thorough understanding of the context of their business.
I think it would be interesting for the audience to also understand where are agents explicitly being deployed today.
In the context of engineering, I just saw a demo in one of our conferences. One of our partners worked in the context of a customer where they created simulation AI agents. So as John was explaining, the simulation is it's an end-to-end process, starting with CAD, meshing, applying boundary conditions, creating a solver deck, submitting a job, downloading the job, understanding whether the job ran successfully or not, and making some design changes and doing this design iteration, right? The design validation process. So there are multiple opportunities in this entire process to deploy an agent. For me, I come from the process automation background. So this is AI agents are the next evolution of process automation. So where the AI agent has the smarts of a machine learning model, and then it has the capability to automate the task as you would do in a traditional workflow automation. Mm-hmm. So you don't have to have humans involved in the loop if you choose to do so, right? So to me, it's the next natural evolution. If people have already invested in robotic process automations and things like that, AI agent based automation is going to be just the next step. It is just, the version 2.0 of that, where certain decisions are being autonomously being done with the appropriate guardrails in place.
I'm super excited. John, go ahead.
Not much, to add. I will say to what I do that hasn't trickled down, yet. I will say we're still in the very early, stages. We use perhaps a little bit, that behind the scenes on developing code and testing, code. But it's not something that has been, widely democratized, yet. A little bit, we have some, concepts. We even have released something that helps with, going over our e-learning things and, documentation, and help you, somebody find how to do, things. But we haven't got yet to the point that the agents actually execute. But, I can see that, happening, soon.
Definitely early stages, but the demo was exciting. So the agent, basically a simulation agent, launched HyperMesh, which is our preprocessor, automatically extracted a CAD from a PDM system, meshed it, created a solver deck, submitted it to the HPC. Then it waited for the job to finish, downloaded it, post-processed it, and gave you a result, right? So there is a early stage demonstrator that I saw, but likewise exciting.
Yeah, I'll talk about, I think we'll talk about the same part. I'll demonstrate it also tomorrow in my speech.
Oh, nice, yeah.
I'm wondering, from a job role perspective, I feel like the engineers, at least my understanding, maybe feel free to correct me if I'm wrong, I feel like engineers have to become more of a generalist rather than a specialist. Of course, there still need to be the specialists who take care of the deep tech stuff, but I think the general engineer, like the broad range of engineers, become more generalists. Because I think we might need to become prompt engineers in the future who actually know how to prompt specific AI agents to achieve a specific task. Do you think that's true, or do you think that's wrong?
I don't fully agree with that. I mean, I can see, that scenario, also existing. But, what we do is, in engineering has so many different fields that requires, expertise. So at least I see more potential for this initial implementation to be by these specialists, in the field, to help them get the job, done, faster. Eventually, if we get to, the agents put through their paces, through these people, and get even further, training, and get, we can, let's say, transfer that deeper expertise, to the agent, perhaps we can get to a point that those could be usable for a more generalist. But I will see the first wave of implementations. I see it more on the specialist side. At least that's my opinion.
Interesting. Fair enough.
I lean towards the generalist side of the fence. I signed up for mechanical engineering because I felt that mechanical engineers are generalist. Civil engineering, electrical, and computer science. So we have a pretty broad general understanding of that, and not deep in electrical engineering or civil, but we do understand the concept. So I think it kind of helps when you're getting responses which you may not be familiar with, but if you have a broad understanding, you can at least get a feel that, hey, this is making sense, it's intuitive for me, and then maybe drill down or learn more, or bring in an expert to get their opinion on the results, and hey, what do you make of it? So I feel that having a generalist, broad understanding, helps tie things together as well, and I think the future is there, basically.
The where I was differentiating a little bit is that it's also an issue of trust, and I think in having going through the specialist first that can critique and understand the results deeply is where it's going to develop confidence to the technology. That's why I said I see that first, getting through that route to eventually, go to the more, generalist efforts. It's more proven and more, relied on.
I have a follow-up question to you, Yeshwant. You mentioned process automation. Do you feel we need process automation to democratize, or is democratization a baseline to process automate something? In which way do we go first? First process automate and then democratize, or vice versa?
the automation can abstract, somehow provide coverage, whether the specific task or tool is democratized or not. I think an automation can abstract that. But I truly believe that first you need to identify, hey, here's a business process, here are the different tasks, and what in this business process can be automated, and how can you automate that? And should that task be automated by an AI? Is one of the decisions that you need to make. So I feel that question whether the AI is democratized already or not is secondary. It's not pertinent. And like any technology adoption, right? The hype cycle, the hype curve, you will have a slice of early adopters who will not wait for democratization, right? And there'll be a slice of customers who are going to wait for it to plateau off and then adopt. This is one area where I think the AI is being rapidly going through this hype cycle, right? Within 5 years, we have gone through pretty much the entire emergence and the peak, and now in the valley of adoption high.
I think it's kind of like the chicken and egg question here. They go together. And I was putting emphasis earlier on making things, transparent. So you hear we're talking about many times about how to do things with no code, low code, right? So an example that I can get for automation is when you use our tools and you use the regular tool interface to design something to develop your model. We have an option to pretty much record that, but not only just record a session, but spin out the, let's say, Python code that generates that. So that is an enabler, for then to do the, the automation. So I think by doing this, you creating the building blocks to make this process automation, much easier and driven by agents.
Very interesting. You talked about the hype cycle. And when we talk about the Gartner hype cycle, do you think we're at the peak now, or do you think we're at the valley of despair, right before the plateau is happening? Where do you think we are? It depends, obviously, like
the application, right? Yeah. Because AI is such broad, you have multiple applications. So clearly, on certain class of Gen AI and LLM application, it is beyond the disillusionment and in rapid adoption, right? Especially external facing, customer facing tooling, right? Any support that you interact with, whether you're cable service or phone service or airlines, the initial first line of defense is you're interacting with a LLM initially, and they have gotten a lot better, and in fact, I've had reasonably good experience with them. I feel it depends on the application, and clearly on the engineering side, we are still, in the early stages where 3D is involved, but clearly in the natural language side, and other modalities like vision and language, and code generation, things are real well into adoption and beyond the disillusionment phase.
Yeah, I agree. I think on the engineering side, we're still early. There's a lot more to come, and a lot more that we actually don't even have thought about yet. Because the more we do, the more options we see opening up.
What do you think are potential threats or risks when engineers are trying to adopt AI in the organization? Do you feel like they don't take the crawl, walk, run approach? They want to fly immediately? What do you think is the problem here in the industry?
I personally see from engineers are very skeptical, people. So they will use the things and they will usually, cross-check before they, fully believe. I think it's part of the training. We always been taught to use our judgment about things. So I think that's also, I think the reason it's going to take a bit, more time, and we're still, early because there's, critique like the big hallucinations that you got for the early LLM models, and there's no way we can deal with that in engineering.
Yeah, so I think as consumers, I'm an engineer as a consumer. As a consumer, we have rapidly adopted AI, right? In a daily life, unlocking the phone to automated driving, we are consuming AI. And it's engineers as well as the enterprises are a little bit more conservative, obviously, right? They need to de-risk stuff when they adopt a new technology. But when John and I started the career in this simulation space, the industry was going from everything, you design a part, you build a prototype, an expensive prototype, and you actually physically test it, right? And from there to computer-aided engineering, which was our Siemens and Altair's portfolio of products. How can you not make a prototype, virtually validate that product, right? So this is that inflection time now where you had the computer-aided engineering, now you have AI-enabled engineering. So there'll be the similar challenges of transitioning from physical testing to computer-aided engineering to AI-enabled engineering. We need to prove that it works, and then I think adoption will come. Yeah, it's just a matter of time.
What do you think does it mean for AI in engineering that Siemens acquired Altair? Will it accelerate the adoption of AI in engineering organizations?
I'm personally super excited about it, and I think it's the one thing that Altair did was we embedded AI into the tools that engineers use on a day-to-day basis. They don't have to come out of it and experience AI. It's just right there within HyperWorks. And I think with Siemens, we can actually push that downstream, right? You have the NX platform for designers. So this whole notion of upfront design validation can be now pushed in where as soon as the engineer is changing and designing, an physics AI powered AI agent can say, yep, the design is in the right direction. You can do a high fidelity simulation later on, but at least early in the design phase, you're not making decisions that are not fixable.
I see the synergy there that we can expand, the audience a lot because Siemens is very strong also on the manufacturing side, and we have, great tools, the manufacturing and our digital twins, for example, not only for building a model, but also monitoring the life, of a product and predictive maintenance and all this that we can do. But it was not our, let's say, core, business. We're more on the, product, design area. And I think now with Siemens, we can, expand our reach there, and also because we develop technology, this technology can proliferate to a lot of, let's say, existing Siemens products not coming from Altair. So the technology that we have can spread out to a lot more products and a lot more audience.
Absolutely. For the audience, or maybe people listening to this podcast, they say attention is the new oil, right? There's a lot of papers being published every single day on AI. So how can you, as an engineer, start with AI? What would your recommendation be? I know I love Altair, by the way. When I was studying, I know there's a 3-part series on data science and engineering. And I used to watch that when I was still studying. I believe that this is like a couple of years old. And Altair does a lot in terms of like producing content around AI. What would your recommendation be? How you want to get started, or how people should get started in AI and engineering?
I would say it depends on, what you do, of course, but for somebody that is a simulation, engineer, our pre and post-processing tools allow them to use, AI many times without even knowing that they're using it. So that's why I was saying is like how you implement it, it makes a big difference in adoption. So this will allow them to get their feet, let's say, wet, much easier, and then perhaps develop, that interest, and then start realizing, oh, what's happening here, and get more and more and more, deep to it. But I think, Altair offers a very, let's say, easy entrance to this.
Yeah, so we are kind of unique in the sense that not only we are consuming AI, we are integrating with engineering tools that we have, design and engineering tools, and manufacturing tools, and embedding AI within them. But also we have a platform which our customers can use to develop these agents and AI applications called RapidMiner. So that's basically a horizontal tool, domain independent, capability where one can develop AI applications. So as part of that unique intersection, so you can have both, in our learning center, like you were mentioning that we've released, that series of, topics to get an engineer up to speed with data science. So that's published on our learning center. You can start there as a general idea about machine learning, AI, and then you can see in our tools or with how that is being applied within HyperWorks and how it impacts an engineer within that tool, right? So it's all available in our learning center. Yeah.
Last question before we wrap it up. What is AI not for engineers? So what are some of the misconceptions and things engineers shouldn't be doing with AI?
I think something that I'm hearing is like, okay, you don't need to be an engineer anymore. You can ask the AI and it will do it for you. No, I don't see that happening.
Okay.
At least in the foreseeable future.
Yeah, I mean, I think there's a lot of things that AI can do, and I think, as I was mentioning, engineering is definitely a hard topic. Let's say even the code generation. Yes, you can develop simple applications completely automatically, but any enterprise class application that has a unique business logic, you need to still put your mind behind it. So I think on the engineering side, clearly, it's truly a way to improve your productivity, and like John was mentioning, to explore all your design options. Earlier on, maybe you were constrained by time, and now, since you can do more within a given period of time with AI, you can explore the entire design space and pick the design that works for you, right? So that's the flexibility that you're getting. Any tool that you use, you need to know how to operate, and I think it's the caution. The universal caution that I would say.
So I'm definitely excited about the future. John and Yeshwant, it's been a pleasure.
Yeah, very nice talking to you. Yeah. Thank you.
Thank you.
All right.
So that has been another episode of the Realize Life podcast 2025 here in Amsterdam. If you enjoyed the session, make sure to leave a comment, leave a like, and make sure to subscribe to the channel.